All right, let's go through this PowerPoint over analog components. Click here. So what we're going to do today, we're going to talk about some common components that we're going to use throughout the course of the year, and how to identify them. So the first thing that we are going to use and talk about is resistors, and we use these in PoE, so you ought to be a little bit familiar with them. Okay. The main type that we're going to be using for the purpose of this class is the one that you see. Let me unfreeze my screen there for you guys. Top left there. Okay. The 4-band, right? We also use potentiometers in class, and you guys use those in PoE for your VEX components as well. We won't see any 5-band resistors for class. You might see some surface mount resistors later on in the year, but for the most part, the ones you guys are going to be using are the ones in the top left. And you can see the schematic symbol for it there. You can kind of see a general size comparison of those resistors. The thing that is important to notice here is that, let's say I had a resistor that was 330 ohm. It could be like this one down here, this kind of aqua colored one, or it could be the size of the red one. So just depending on the manufacturer. So don't get twisted up about the size. If you get sometimes I order them from a manufacturer and they're bigger or smaller, but you still have to pay attention to just the color bands on it. The color codes are going to tell us what they are. We can also use a multimeter to tell us what they are to double check. You guys on have this up on the wall. It's also in the formula sheet. And this is the resistor color code chart. Some of you have them on your desk too. I tried to hand those out. If you didn't get one of those on your desk, you can come get one there. So we'll look at that. They're pretty straightforward. The thing that you want to know about the resistors that we're going to deal with in class are all going to be gold bands. And so if you ever pick one up and you don't know which way's left or right, just look for that gold band, and it's always going to go to the right. So if we looked at this one right here and we said, okay, first band is brown, and we can look down and see brown is a 1. Now, if you're colorblind, I don't know how you read these, other than you just would have to use a multimeter. So then the second color is black, and so that's a 0. So we have a 1 and a 0, and then the red is our multiplier, right? And so we see that our multiplier is 100. So if we did the math, 1, 0 times 100, 10 times 100 gives us 1,000. So, and we'll let it do that for us. And so we have 1,000 ohms. Now, the correct way to write that would be 1 kilo ohm. Okay. Then we've got another one here, and we look at, we go orange, white, green. So 3, then white is 9, and then green is 100K. So 39 times 100,000. So that'd be 39 times 100K, which gives us 3,900 kilo. I don't know why they did the kilo ohm. I would just go straight to the mega ohms. That's kind of what makes more sense. So that one's gonna be a 3.9 mega ohm would be the correct answer for that one. Then it says, all right, if I've got one and I just said, hey, 1.5 kilo ohm, what is my value? Well, 1 is brown, 5 is green, and then I would need to add 2 zeros to that. So that would be red. So we go brown, green, red, and then of course the tolerance, plus or minus. Yes, it does matter. So, because nothing but the best for y'all, all of mine are the ones with the lowest tolerance, the gold. That's good because it's going to be less likely to be off, right? So I spare no expense for you guys, and we get just the gold ones. Well, yeah, the school pays for it. Yeah, the school spares no expense for y'all. Now we're going to talk about capacitors. And capacitor, basically, if you don't know, is like a little battery. They're named after Michael Faraday. And here we go. The ones on the top left and kind of the bottom left are going to be the ones that we use in class. The ceramic disc capacitors and then the electrolytic capacitors. The difference that you need to know about these, the big thing here is that the ceramic disc capacitors, doesn't matter which way you hook them up. They're like resistors. They're bipolar. The electrolytic, I can't say that today. Never mind. Electrolytic, thank you. Capacitors, they are polar. It matters. So when we're going to do a project here called the random number generator, you guys are going to solder. There's both types of capacitors, I believe, on that guy. The ones on the bottom left, you have to pay attention. Notice that you've got a one leg shorter than the other one. That's usually a good clue that that thing has to go in there a certain way. Okay. And then we have some others. Now, when we look at these guys, these are pretty easy. They're going to just tell you what the deal is. If it doesn't tell you, the default is going to be plus or minus 20%. So you just need to kind of remember that. And these are almost always measured in micro Faraday. So you can see that there, micro. And so you just kind of read them. So they're pretty simple. Now the disc capacitors, you'll need this chart from the PowerPoint. I don't think it's on the homework doc, but it operates first number, second number, and then the number of zeros. So it's pretty simple. So 4, 7, 2 zeros, that's 4,700. Now, then the deal on this is they're always going to be in pico Faraday, so always go pico de gallo on these guys. And then you can look at the letter is going to tell you the tolerance, and that's on this chart right here. So this one's K. When we look over here, it's plus or minus 10%. If it doesn't have a letter, its default is going to be plus or minus 20, just like the other ones. Okay. So you look at this one, you go, okay, 3, 3, 1. So it's 3, 3, 1, 0, and then J. So 3, 3, 0. So 330 pica. And then J is plus or minus 5%. There you go. And we look at this one, and it's 103K. So 103, that's 10,000, right? So we're going to 100. Now it's going to always put it pico. Now but it's probably it might convert it into something else. And that's fine too, but we're good. You can always give them to me in pico. That's fine. Now let's talk about some other things. LEDs you guys are familiar with. We have a 7-segment display up there, and those are just LEDs too. And we'll talk more in greater detail about those. See those like on scoreboards or that digital clock up there at the front of the classroom. Diodes and fuses and voltage regulators. Later on in the assignment, you're going to have to identify a voltage regulator, so pay attention to what it looks like. Diodes are polar, so it matters which way you hook them up. And that's the end of the slideshow. Your assignment is on Google Classroom. Let's open that up real quick. So you go here, and we're going to go to Component ID. You've got to complete this assignment. Here it is. Yes, you have to do the conclusion questions always. You're going to make sure you type in red. Okay, now here's the example. When you're typing on this guy, you're not going to be able to type a plus and a minus together, but make sure you can just hit plus and then hit the dash key for minus. So don't worry about trying to find that. Same thing for the ohms. If you have to put omega in there, you can just type out ohms, or if it's micro, you can just put a U. So just because I know you're going to be typing, just make sure you type in red. You're going to do all of those. Then you've got these capacitors to do. And there is a copy of the resistor. Oh, there is a capacitor thing on there. I couldn't remember. I didn't think it was on there. I thought you had to go back. Then you got conclusion questions there, and let's talk about that. So if we were actually measuring those, I took out part of the assignment where you actually have to go in and you read them, then you measure them because people at home don't have multimeters to read them with. And so it says, what's the difference of the values of the nominal value? Okay, so if we measured something, why would it be a little bit different if we actually measured that resistor? Try to think about a reason why it might be a little different, going back to IED and precision and those types of things. And then here's that chart that you've got to identify all those things on. The only thing on there that we didn't cover in the PowerPoint is C. Okay. And does anybody know what C is already? It's an integrated circuit chip. Okay. An IC is good enough to put in there. Okay. So I'll help you with that one since it's not on there. All right. You should have plenty of time to finish this here in class.